Hello, and welcome to today's online panel discussion. And today we're talking about the future of semiconductors in a global market. My name is Mark Elliott. I am the COO of Europa Science, which is a publisher of Electro-Optics. Welcome to everyone that's joined us. We are going to spend the next hour or so exploring how the semiconductor industry is evolving to meet changing demands. As we all know, semiconductors are really powering the technologies that define our modern world. And you know the list: smartphones, electric vehicles, renewable energy systems, advanced medical devices, and of course, the most powerful AI supercomputers. And we know, of course, that optical solutions play a critical role in semiconductor manufacturing, from high accuracy wafer stages to laser control for lithography systems, optical metrology and inspection. But of course, as chip performance increases, the demands on semiconductor equipment rise accordingly. And this is bringing additional challenges on optical components performance, as well as supply chain resilience and efficiency. So this online panel will, I hope, discuss and examine innovations in material science, strategies for scaling production, the collaborations you need to maintain global competitiveness, and of course, how to choose the right supplier. It's quite a meaty topic, but I'm pleased to say we've got three men who really know what they're talking about. I'm going to introduce them now. So first of all, we've got Howard Ruprecht, who's the Managing Director of CS Connected. Howard has enjoyed a 35-year international career in the microelectronics industry in both technical and commercial roles. He started as an engineer and then spent 15 years in sales, marketing, and business development. Previous work has focused on technology commercialization at a European RTO, and where he's been implementing initiatives to assess innovations and fund the incubation of new ventures. He's worked with deep tech startups in the US, Finland, and the UK, and is often working at the intersection of the public and private sectors. Howard currently manages CS Connected Limited, which is supporting, of course, the growth of the Welsh compound semiconductor cluster here in the UK. Welcome, Howard. Thanks for joining us. Next, we have Andy Sellers, who's the Director of Strategy at Cornerstone, which is, of course, a spin out from the University of Southampton. Andy focuses on developing and implementing strategies to maximize the commercial application of PICs. He is the co-chair of the Semiconductor Expert Working Group for the UK Telecom Innovation Network and serves on the government's Semiconductor Advisory Panel. Andy has given expert evidence to parliamentary inquiries, including the National Security and Investment Act, the Telecom Security Act, and, of course, the Select Committee on Semiconductors. Welcome, Andy. Thanks for joining us as well. And last but certainly not least, we have Simon Gubser, who is the commercial head of the semiconductor market at Materion Optics. Simon brings more than a decade of experience in the optics industry, spanning from semiconductor chips packaging to integrated optical systems. He holds multiple patents in optics manufacturing and has been at the forefront of optical technology innovation across areas such as consumer electronics and semiconductor equipment. Simon is a driving force of Materion Optics' high-performance optical coatings and prism assemblies, and is making sure that they meet the demands of major semiconductor equipment manufacturers. It is timely here to say thanks to Materion for helping us to present this today. It's been a very productive partnership, so thanks for its support of this topic, which I know our audience is fascinated by. A quick bit of housekeeping, if I may. These online panel discussions are designed to be useful but also interactive. So we would welcome any questions from you too. So please submit them at the bottom of your screens and we'll do our best to tackle them across what I hope will be a full and lively discussion across the next hour or so. So welcome again to all three of you. It's great to have you on board and to have some real expertise on this topic. We are going to start nice and gently with a fairly broad question about what you would define as the most prominent supply chain challenges facing the semiconductor industry today. Howard, I'm going to pick on you first, if I may. So welcome, Howard, and yeah, tell us what you think.
Thank you very much. Yeah, I think that's a really good question. And, I would characterize it by you certainly have a change from the previous norms, particularly in trade, geopolitics, onshoring, that kind of thing. So we've gone through this period sort of from the early 90s through to about 8 years ago where everything was getting increasingly interconnected and globalized. And then suddenly everything changed. You know, you can almost start with Brexit, but I'm not saying that's the reason. But beyond there, you sort of see this disintegration and changes happening within the supply chain, and the current tensions that you're seeing, whether it's China, Taiwan, whether it's Russia, China, the US, those kind of things. This is not what we were used to 15 years ago. And so I think there's this period of readjustment that is really starting to happen, and big trading blocks are saying, how do we be independent in our ability to continue to make strategically important semiconductors? And so you're sort of moving on from that, you get into the whole things like availability of materials. So only this week we've had the discussion about rare earths and China limiting exports of that, and the US, threatening tariffs or further tariffs as a result of that. But it's not just availability of the materials, it can also be availability of equipment. I think we all know that ASML won't sell the latest equipment to China because of US trade restrictions, et cetera, et cetera. So these are, some of the things that we hear about every day, and we tend to see the results of them in something like COVID, when the supply chain got disrupted, or when an earthquake happens, or whatever it may be. The third thing I would add, which is becoming increasingly prevalent, is of course cybersecurity. Now, I'm certainly not an expert in this, but it's really shocked me in the last few months how many big companies are literally being brought to their knees by an attack. JLR, I think there was an article today that said it's cost it 1.9 billion, and they were out of production for the best part of 6 to 8 weeks as a result of a cyber attack. And we haven't seen that happen yet. What's going to happen if TSMC is hit or somebody else is hit? So I think there's further risk in the system, and I think that risk becomes more from cyber than from anywhere else.
Gosh, yeah, you painted quite a bleak picture there, and it's Howard. I mean, it's one of those things where I think in the last 5, 10 years, I suppose, yeah, as you say, the world has shifted dramatically. Andy, how is that playing out in terms of the manufacturing side? And there's a bigger question, isn't there, about the ability for organizations and governments to respond to those challenges. So pick your lane, but if you could kind of try and touch on both of those bits for us, would be great.
Yeah, absolutely. I agree with Howard's summary there, that kind of how we got to where we are is really the country started to specialize. And in some ways, that's a good thing. Specialization drives down cost and it drives up innovation, but at the risk of developing complex supply chains. And we didn't really realize how complex the supply chains were until COVID. And all of a sudden, you're missing a component. And I think what has really happened is governments have started to recognize the strategic importance of semiconductors. So the entire economy is built on semiconductors. The ability to communicate, to trade is all built on semiconductors. And what we're starting to see happening is, firstly, that has ramped right up the political agenda, and political domains are starting to group together in terms of how to address it. And I think one of the reasons why we saw this kind of specialization is that quite often you only need one fab to make all the high-end chips in the world. So it's an extremely capital-intensive industry. To build the fab might cost $20 billion. So once you've built that fab and once you've got that manufacturing process absolutely locked down, that fab can supply 80%, 90% of the world's high-end chips. So really, the economics doesn't tend to naturally support multiple suppliers, and that's why governments have started to intervene to say, well, actually, that's now a single point of failure. We can't really live with that going forward. We need to start looking at sort of diversification strategies. So the US in particular, initially with the CHIPS Act and TSMC investing in Arizona, and then more recently investing in Dresden. The European Chips Act, which has actually made a recent sort of announcement to sort of step up its investment. They've actually done an assessment of where they are. They launched the European Chips Act was around about the same time as the US Chips Act. That both had around about the same value, but the European Chips Act has recently reviewed where they are in terms of process and has decided to try and accelerate things. So certainly the governments are sort of taking this very seriously. I think the other thing we've seen a subtle change in the US is perhaps a move away from an emphasis on the Chips Act to Trump's approach to managing trade. So that's a subtle difference, but certainly the direction of travel is to try and repatriate more production capability back into what we'd call like-minded nations. That certainly is the direction of travel.
Okay, thank you. And Simon, what's your perspective on this? So, both in terms of the geopolitical and the technology as well.
Yeah, where do I even start? But besides the geopolitical challenges, I think from a perspective from a equipment manufacturer, it's also from a technical point of view, the extreme technical requirements for the entire supply chain. I mean, let's take something trivial like a prism, but if I get requirements to side needs to be flat to lambda 100, and for the whole supply chain, glass manufacturing, prism manufacturing, coating, disassembled in the system, you need to control that, and the measurement is so critical or sensitive. Every party who measures it will measure slightly different. So you need to align through the whole supply chain what you're actually measuring and how you're measuring. So it's additional effort. Can be quite cumbersome effort, but takes more and more of the actual value creation. And the ongoing push for performance will further put pressure on this, I think. Yeah.
Okay. Howard, I'll come back to you if I may.
Yeah, I was actually going to add to some of what Andy was discussing about onshoring and having capabilities, your own capabilities. And I think it's really to make the distinction between sovereign capability and sovereign independence. And we have to realize that no one country has the full independent capability to do everything to the highest level. And even the US doesn't have the leading edge in lithography that's coming from ASML. So, the point here is a sovereign capability is something that you can essentially trade and is essential somewhere in that supply chain. So in the UK, whether it's chip design, whether it's photonics, or whether it's compound semiconductor, there's areas where the UK is leading and can therefore plug into the European and the US supply chains with a critical part rather than doing everything from soup to nuts kind of thing. So I think it's kind of an important distinction to make that onshoring doesn't make you completely independent. And, again, America can't do much if it can't get rare earths or it doesn't have the latest lithography equipment. So we're all in it together. So you've got to be part of a block now and have something to trade with that block.
That's a really good point. It feels like it's a realignment of alliances and interdependencies as much as anything else. Andy?
Yeah, totally agree. I think the other, to kind of build on that point, is the economics doesn't support one country having its complete sovereign capability. It doesn't have the market within a single country isn't sufficient to support the entire supply chain for one particular type of semiconductor. So it is about having alliances and finding out where each country has its own specialization. But it's a realignment. I think the globalization was it went to the far corners of the earth, and we're now starting to say, actually, we need access to technologies, we need access to equipment, we need access to materials. Who are the best partners to work with? What are our strengths? How do we trade our strengths with like-minded partners? And what are the strengths that they bring to the table?
There's an obvious supplementary question. In fact, I think there are possibly two. I'd be interested in the panel's view on if anybody wins out of this. We've talked a lot about investment, and that's obviously a big opportunity cost. But does anybody come out of this in a better place than they started? And the other obvious question is it cyclical? If we were doing this 20, 30 years hence, would that glow, or is this the new norm for as far ahead as we can see? Andy, I'll stick with you as I've got you. Sorry.
That's a good question. I think I think if we went back, the origins of all of this, really, the sort of the fall of the Berlin Wall and the unification of Europe, and that kind of drove a lot of globalization, and a lot of industries looked how they could then partner with the Far East, and there was a much higher degree of trust. And also, I would say that at the time, the sort of the strategic importance of semiconductors wasn't quite as critical. Now they're absolutely fundamental, and I think there has been some element more recently with a breakdown of geopolitical trust, and that's really what's starting to drive this kind of separation. So could it be cyclical? Who knows? It kind of it's never impossible with politics and with cultures, and these things can evolve and they can change. So perhaps in 100 years' time, we'll be looking at alliances with countries that we don't trade with at the moment. That's completely feasible.
Yeah.
Who wins? That's a very good question, because that kind of asks the question about where is value created in the supply chain. And this is kind of, the theory of Michael Porter, if you go back to his sort of economic theory about where do you capture value in the supply chain and how much control do you have over your suppliers and your customers and that sort of thing. And also the role of intervention in order to secure your position in the supply chain. And on the whole, it's probably fair to say that Western economies have not been particularly interventionist over the past 30 years, and it's been more kind of market-led. Whether that's a good thing or a bad thing, I'm not sort of drawing that conclusion. But the UK in particular has tended to focus on design. So the UK is probably a leading design country in the world, in fact, in terms of, especially in sort of terms of complex silicon chips and in other and also new materials. So new materials and design has really been where the UK has excelled. Where value will be created as we go forward, design will certainly be important. I'm absolutely certain of that. And probably the fabrication as well, the value in the fabrication, and specifically the advanced materials that we might take.
Okay, thank you. Simon, obviously for a company like Materion, I mean, how far ahead are you able to look, and do you kind of try and model this and answer that question internally?
Yeah, definitely we try. And I think alliances will remain, because there's such a high degree of specialization. There's a reason why ASML is not just copied on the short term, so that will remain. And I think, as Howard mentioned earlier, some rare earths, they are simply not everywhere. So there will always be this trade, and therefore I think there's not a clear winner in the end. I mean, couldn't tell yet, and where is value
back in 10 years? Look, yeah.
And where is value created? Maybe, I mean, today we talk mainly about AI and the highly advanced nodes, but let's not forget, this is not the nodes that are running the world. So it is the more mature nodes that I think, it will maybe not become a commodity, but it will commoditize a bit more. And there, that will be, maybe countries can look for themselves, or continents by their own. But being at the forefront of what's possible, I think it will not happen without alliances.
Okay, and Howard, I'll come back to you and then we'll move on. Thanks.
Yeah, I mean, I'm glad Andy, raised the whole question of value capture, because it's fundamentally about what you do, what activities do you do, and what money you make from doing it. And the UK particularly talks a lot about ARM and some of the fabless companies. But we still do an awful lot of manufacturing, admittedly low to medium volume specialty semiconductors, but that's very, very sticky and much higher value capture. So, and it also creates much more employment in terms of, let me give you an example. ARM is a $3 billion company in revenue. Vishay is about a $3 billion company in revenue. ARM employs 7,000 people. Vishay employs 22,000 people. So if you go and look at some of the SIA reports from the US about the structure of the US industry, there's 2 to 3 times more jobs in manufacturing than there are in design. And actually, those jobs are at much more multiple levels. So the distribution of wealth, should we say, is much greater, and they also have more complex supply chains with them. So to repatriate manufacturing definitely helps with value capture. I'll leave you with one other thought. If we take the latest chips in an Apple phone, although they don't publish numbers, the rumor is that ARM make less than 5% royalty on the value of that chip, whereas TMC is supposedly making 40% of the value capture on that chip. So is it good to be manufacturing or is it good to be design? You clearly need both, but who captures money and where becomes really critical. And actually, maybe I'll give you a good segue into discussions about AI. But if you look at the stack in AI at the moment, who's capturing all the money? It's actually in the hardware layer, but I don't think that will remain forever.
No, I think that's absolutely right, and that you're right. That's a perfect segue into the next question. None of these discussions, in my experience of late, have not discussed AI at length, so it's natural we come to this as the next area to look at. Obviously, it's at the top of mind for almost all of us in different ways, but particularly across the global semiconductor space. I'm interested in the manufacturing demands evolving to meet these rising power demands, and I'm trying to understand how optical solutions can help with this. Simon, I'll go to you first, if I may, on that. So how are we helping the AI revolution?
Definitely. Yeah, on the one hand, I think the incremental progress continues. I mean, such as improved architectures of the chips, lower, less optocouplers, and so on. But I think the real breakthroughs will or have to arrive through innovation. Otherwise we don't get there. And yeah, I'm curious then to hear my co-speakers' opinion, as for me, like PICs or like something like core packaged optics are in a prominent role here to at least reduce the power needs. I mean, the overall power will not come down, power need, as AI is here to stay. But how steep the slope or how much we can flatten it, I think this will come through innovations. And I think, yeah, let's say PICs, I think for me is something here. And looking a bit more into the future, I think today we're mainly talking about powering data centers, what is quite straightforward and not completely true. But if you look at, the future is edge computing. You have some AI in your phone, on your car, you're on autonomous driving cars. It should not crash and there's no data reception. So, and powering it decentralized, I think is even more challenging and will put pressure on the innovations.
Yeah, absolutely. You can see the obvious direction of travel. I think that's absolutely right. But the intricacy around power management in those scenarios is just slightly beyond certainly my understanding or kind of imagination even. Andy, obviously you'll be kind of quite close to this in terms of some of the work I'm sure you've been exposed to. What's your take on this? I mean, in terms of the AI opportunity and how semiconductors and optical comms are kind of helping in this regard.
Yeah, absolutely. I think, Simon's right. The power that's required for a data center is significant. Maybe I've heard the figure that it's typically the same as what you get from a small modular nuclear reactor. So you're getting to a situation where each data center could have its own modular nuclear reactor powering it, which is quite an unprecedented situation to be in. I think some of the trends are certainly towards AI at the edge. AI at the edge is more responsive. It is lower energy consumption. It's got lower latency. It doesn't have to communicate back into the hyperscalers. One of the other trends that we're starting to see is even sort of low precision compute. So some research that's been done at Google. Historically, microprocessors started off being 8-bit micros, and they went to 16-bit, then 32-bit, and that has been the driver. Has certainly been sort of increased bus sizes. Increased bus sizes clearly increases the area of the chip and the complexity of accessing memory and what have you. Low precision compute, on the other hand, actually has some really major advantages. Reduced bottlenecks, faster processing, much lower energy. So that's one of the directions of travel. I can see sort of the chips being optimized for sort of low energy compute. But the other area is neuromorphic and analog and optical compute. And I was actually yesterday, I was at the launch of the UK's Multidisciplinary Centre for Neuromorphic Computing in the House of Lords. And a typical electronic solution to computation might require 2 kilowatts of power, and they're comparing that with the brain, which is still more advanced and does it in less than 20 watts of power. So it's a phenomenal, you know, okay, we've had sort of 50 million years of evolution to get there. But one of the questions being asked was, if you were to start from scratch, would you start designing a computer in the way that we've done it conventionally? Would you start using on-off switches, and would you have digitization and all that sort of stuff? And there's a whole bunch of advantages with that technology. But at the same time, optical compute, analog compute, and neuromorphic computing, which is kind of effectively modeling how the brain makes its decision processes, is much more responsive and much more efficient. And I can see that you know, that one of the foundational platforms to achieve that is going to be photonic integrated circuits. So I can see that certainly is the direction of travel to get low energy AI.
Gosh, yeah, that's quite a you know a debate, right, isn't it, about, you know, whether the journey we're on, you know, whether you know, knowing what we know now, whether you'd actually go back to the beginning and go off on a completely different tangent. It's yeah, fascinating. Howard, any thoughts on this AI kind of challenge stroke opportunity?
Yeah, absolutely. And I think the hyperscalers, you know, I may be wrong on this, but it feels like they've been caught by surprise a little bit by the speed of growth being driven by AI. You know, I worked for a photonics company a few years back, and 10 years ago they were doing work on co-packaged optics with the value proposition around saving power in data centers and top of rack switches. Now, we eventually switched our focus because, quite frankly, the enthusiasm from the FANG companies was tepid at the time. And I think they followed a relatively predictable growth path for many, many years in data centers. And then it feels like suddenly they're going, oh, damn, God, this thing's expanding way quicker than we expected. So I think co-packaged optics particularly is a technology that is now at the right time. I don't think it was the right time 10 years ago, you know, that maybe the need wasn't there. But doing more optically will definitely save power and increase efficiency. I think there's also opportunities with GaN for power as well, for power devices. Now, it's not as big a proportion. But it certainly is a factor that will contribute to savings. And, you know, just to comment on the data centers, they are absolute power vampires, to Andy's point about the modular reactor. And he knows exactly where I'm located, and we're surrounded by 2 Vantage data centers and 1 Microsoft. And the guys from KLA joke about you know, number of employees per megawatt hour used. And if you look at Vishay or KLA or any of the factories around, we have, you know, 50 or 100 times more employees per amount of power used. So these things are very, very big, using lots of power, but they actually don't employ many people, unfortunately.
Yeah, yeah, it's quite scary, isn't it? And
Yeah.
things, you know, you know, and I'm not sure, you know, there was, as you say, much understanding of this direction that we've ended, well, this place we've landed in, you know, even 5-6 years ago, let alone, you know, a decade back. So predicting the future's hard, right? Which is why what makes this topic so interesting, I think. Okay, that was great. Thank you. Okay, let's have a talk about some of the more kind of technical, on some of the more technical levels, you know, around photonic applications and how they can boost accuracy of production. At a wafer level, you know, are we seeing good evidence cases now of this happening? I mean, so in terms of wafer level photonic applications, you know, is it getting better, and why do we believe that? Simon, I'm going to go back to you again, if I may, on this one.
Sure. I mean, yeah, there's no semiconductor production without photonics. Yeah, that's clear. We're about to see the evidence. I think it's more about, yeah, improving those systems. There's not this one component that needs to be improved, and then you get there. Like, yeah, optimizing defect rate, uniformity, accuracy will reflect or will translate into better accuracy on wafer level. The evidence is maybe, yeah, we are getting further, right? So smaller node sizes, whatever, better architecture. I think I would take that as the evidence, yeah. And as mentioned before, also, yeah, it's not the advanced node sizes that around the world. There's still improvement possible at the mature ones to lower cost and yeah, to get it more economic approach. And these requirements will overlap. So what we do now for AI basically will also increase or improve accuracy over the whole portfolio.
And Andy, in terms of, when you're kind of working out kind of roadmaps for improvements and kind of, technology and production advancements, is it easy to predict that pathway, or, are you sometimes surprised by what's uncovered as you're, working to obviously improve all of those kind of measures?
Yeah, good question. I was actually thinking as Simon was speaking there that one of the very good measures of understanding what's coming out from the research base and what new technologies are emerging is actually some of the startups. So ChipStart is the UK's flagship incubator. It's run 3 cohorts of about 10 companies each. So it's incubated sort of 30 companies. So far, they've raised about 40 million of early stage investment between them. Some really innovative companies there, really innovative companies. And what I was surprised, so I was a big advocate of ChipStart before it started, but when it started, I naturally thought ChipStart will all be about CMOS silicon chip design. It was just kind of my narrow view of the world, if you like. And actually it isn't. So about 40 to 50% of the companies on ChipStart are developing photonic solutions. And some of those are using very novel. So some of the complexities, and Howard would be an absolute expert on this, some of the complexities in wafer processing, especially with compound semiconductors, is the uniformity across the wafer. So as you're trying to get from, research base where it might be a 4-inch wafer to production, which might be an 8-inch wafer, or maybe even bigger if possible. But some of the challenges are uniformity across the wafer. And what I have noticed is that some of these companies coming out of, as I say, sort of startups raising investment, are developing some very novel optical scanning techniques and imaging techniques to look for uniformity and defects and this sort of thing. And it's what it will do is you'll put that into your feedback loop as part of the process. So you'll be processing wafers, you'll be measuring them, and then as part of the feedback, you put that in, and it'll improve the uniformity. Ultimately, uniformity is a driver of yield. Ultimately, yield is what is driving the margins that you're making those chips at. So, and as part of the UK's ecosystem, we're in a very good place to kind of make that feedback loop.
So, yeah, Howard, I'll come to you. Thanks.
Yeah, I mean, I'd agree with Andy. I think there really is some outstanding innovation in the whole area of optical measurement and metrology. And I previously worked in Finland, which was also a very good hotspot for those kind of things. I think actually the key that you're seeing is we have to be thinking long term of the metrology being in process and in line rather than offline and destructive, because just the loss of taking a wafer out and doing tests on it in a lab environment and taking it out of production is a yield loss in itself. So I think it's really taking these things to a high volume, or not even high volume, but a medium volume inline mode is probably one of the significant challenges going forward.
The scalability and the standardization, I guess, is a fairly uniform kind of requirement in terms of growth and sustainability with some of these sort of technologies. Is there a kind of takeaway where you see these kind of checks and balances going routinely wrong? So I'm just kind of trying to understand if there are kind of obvious things that you see from whatever angle you're involved in on some of these processes where, people are just not making the right calls at the right way or looking for the right things. Is there anything that springs to mind around that? So the question basically is, what should people be looking out for and what can they do to avoid hitting problems? Simon, I'll go back to you again, if I may, on this one. So what's going wrong in terms of that standardization and scaling up?
I'm not sure if something really goes wrong there in the standardization. I think it is to some extent a bit of a trial and error. Yeah, you're always at the forefront of and pushing the limits of physics. So yeah, you get to start somewhere and you need to change direction on the way. I think that's clearly. And but once it gets into manufacturing, I think these for various iterations, it's gonna really be more like incremental improvements, but we are getting there. And I think Howard's point was pretty good. Yeah, to having it in line and not taking wafer hours for metrology. And I think we see there also the push, like doing with optics as much as possible, not like scanning with e-beams. I mean it's more accurate, but more expensive, slower, not mass production. And we see there, and I think this is where we see the craziest requirements at the moment, like measuring with light, offset of layers at the single-digit nanometers. I mean that sounds crazy, but it is possible. But you need top notch for the entire supply chain. So back a bit to the supply chain. You cannot have a weak link in there, otherwise it goes wrong.
And Howard, I know you got your hand up, but trial and error seems, a sensible and obvious point to make. But do companies and do projects give enough time to that in from your perspective?
Well, I mean, my word of caution would be don't underestimate how much effort is required to take or to bring a non-standard process platform to maturity. I mean, we tend to take for granted in logic circuits that you have a PDK and a process that's very well established, and you can jump on a multi-project wafer and get things made. But we underestimate how much effort's gone into making that or making that work. So if you take something like silicon photonics or MEMS, for instance, where you've got a non-standard process that could be looking at completely different parameters, what you're looking for in terms of waveguide uniformity is different to a conductive track. And so, your question is if that's a complex and long process, how long does it take to get it to a level of repeatability, and how much does it cost you to go and do that? And I think the challenge of the IDMs is that you can spend an awful lot of money doing that. If each iteration costs you £500,000, how many times do you have to do that? And you're changing device designs, you're changing process designs, you're working on a given tool set, and it just takes an awful long time. That would be my caution. Just don't underestimate that. We take for granted standard platforms.
Yeah, absolutely. So going with your eyes open. Andy, what are you seeing on the ground with this? I mean, I know obviously Cornerstone specializes in customization and relatively small runs, but I guess the issues are the same, right? They've got to spend a lot of time getting the right construct.
Yeah, absolutely. We've got actually we very recently at ECOC, in fact, we launched an open source PDK.
Yeah.
And you saw that. So that's a real sort of step forward, allowing the community to accelerate the designs of their picks and pick and choose modulators, mixers, and different other structures and what have you. I think at Cornerstone, we've been very successful at serving communities in the prototyping space. So we've done something like over 1,000 chip designs for over 100 customers in 20 plus countries around the world. So we compete actually very well internationally. Across the world. So and roughly 50% of the orders that come into Cornerstone are from companies, and the other 50% are from academics, which is quite a nice balance. So the academics clearly value the positioning because they recognize that they can develop a cutting edge chip. The companies recognize the value that they can get a reliable prototype which they can demonstrate to their investor and help to raise investment. I think what we are starting to hear from the community in general is where do they go next? And we're giving that quite a lot of thought. So at Cornerstone, we're very good at rapid turnaround of small volume prototypes. To Howard's point, getting a process locked down and consistent and repeatable and in modest volumes is kind of the bit that we're being asked quite a lot about. So we're giving quite a lot of thought to that. Some of the customers that we're speaking to are asking, should the UK have a pilot line capability in this space? So that's the sort of thing that we're giving thought to. It's an interesting question because the market complexity and the demands, certainly you wouldn't want to build a 2 nanometer CMOS fab in the UK. That'd be prohibitively, as we were discussing earlier, it'd be prohibitively expensive and we'd be competing with other things and we don't have the market. But in the photonic space, interestingly enough, the diversity of markets and the volume is something that where the UK could potentially compete. And another point, kind of just to echo again something that Howard said, and that is the cost and the investment and the time to get a process mature, do not underestimate. Well, in some ways, that is kind of where the UK has a bit of a core capability. So if it's complex and difficult, that's the bit where you need research intensive activity to get to where you want to go. So, it's not out of the question that we could be addressing these markets. We have very good sort of research base, and we could be certainly manufacturing in some of the where the UK has particular strengths.
Yeah, I mean, it strikes me that as an industry, it's relatively collaborative actually compared to some, but your initiative around some of the open access material is interesting. But I guess if there was more of that, there'd be more kind of shortcuts, I guess, if you like. I mean, it's an ambition, I suppose, but perhaps one not always lined up with the reality of commercial business and everything else.
Yeah, there's probably a fairly good degree of collaboration. There's certainly, we recognise the South Wales cluster for its expertise in compound semiconductors, the Southampton cluster for its expertise in photonic integrated circuits and photonics more generally, Northeast cluster for radio frequency, and then the Scottish cluster, which is certainly again sort of quite strongly based on photonics. So there's a good degree of collaboration certainly across the piece. I think perhaps enhancing that wouldn't go amiss. That's certainly something that we could build on.
Well, I think to Andy's point, also, it would be a waste of time to build a 2 nanometer fab. The kind of devices we're playing in are not relying on ultra fine lithography at the end of the day, and so we're orders of magnitude bigger in lots of cases. So it's still hard to do for different reasons, but we can still do it here, and we can do it with the tool sets and the fabs that we have for the most part.
Yeah. I've got a question then about kind of picking partners, really, which I guess, a lot of people are, kind of fall into line with kind of established patterns. What do you see in terms of that kind of decision-making process? I mean, proximity and the geopolitical things I think we've covered, so obviously there's a kind of a sort of a distance and a security kind of angle on this, but more, if you take that kind of dynamic out of the answer, how do you find people approach organizations? So Simon, talking about your experiences in terms of the types of customers you work with, how are they coming to you? What are they thinking about? Are they thinking about the right things when they start talking to you?
I think joint development is my keyword here, because being a make to print supplier is not going to work. We are we have good research. We are at the forefront, and you need partners that go with you. The requirements are tough through the supply chain. You need a good compromise in technical performance, but also economic aspects. And maybe a bit going back to the other question, exactly. 2 nanometer fab in Europe doesn't make sense, but I'm also a bit afraid that even if you look at photonics, like PICs, but definitely would make sense here. But you need a partner that's willing to go bold and to invest. And I have a bit of fears, it might not happen in Europe. And we will contribute with research, but the value or the winner will be somewhere else. That's a bit But in the end, for our products, yeah, in conclusion, find a partner that is willing to co-develop and bring suggestion on the table proactively, and is willing to change directions through development, because there will be changes. You need to be willing to go as you try to push the limits of physics. Yeah.
Andy, when from your experience, what's the sort of courtship like around finding a partner? Is it a quick process generally, or do they always go to the people they know, or how does that kind of work? And then what happens during that process?
Yeah, sure. I think we certainly at Cornerstone, we tend to sort of operate in two different levels. So we certainly offer a sort of an open foundry service for photonic integrated circuits, but we're also involved in collaborative projects. And I think the natural thing when you're looking for partners is technical capability. Who have you worked with in the past? Because there's always an element when you're doing any sort of co-development. There's always an element of risk and having to get to know the partner well enough to actually deliver the project. There's always an element of technical risk and business risk in bringing that partnership together. So certainly familiarity with who you've worked with in the past and their capabilities, that tends to rank very highly. I think it's fair to say we've got some very strong European partners that we've worked with, and some very strong partners in the US and in fact Canada as well. Canada, C2MI, for example, very well known in this space.
And Howard, obviously, your organization is there to support organizations trying to, move forward. What sort of advice are you giving them, and how's this playing out in the real world?
Well, I mean, clearly choosing the right supplier is important. There has to be good synergies at a process level straight away. They've got to understand what you're doing and have experience in what you're doing and be prepared to co-develop. But it feels like that's only half of the challenge. What you have in the volume mainstream market is you have redundancies. If something goes wrong at TSMC, I guess you can work with global foundries. So there's multiple options for logic circuits as suppliers. What you don't have with specialty process flows is that kind of redundancy in the marketplace. So for whatever Andy's doing at Cornerstone, there's probably not 10 other fabs around the world doing exactly the same thing. If, for instance, there's a fire at Cornerstone, and I kind of joke about that. I worked in a fab that had a fire a few years before I joined, and it's devastating, and it has, knocks you out for an awful long period of time. But I'd actually say probably more likely is corporate ownership changes. And again, I speak from bitter experience, which Andy will know, and I won't necessarily talk about. But if your organization is suddenly acquired by a Chinese corporation, it can cause all sorts of problems. And then, let's take another example. Recently, I'm sure Coherent up in the Northeast. It's now become Octric. But you have a situation there where you have defense components that are important and no alternative supplier, and an original owner who says, I don't want to do this anymore, and this fab is no longer viable for my business. And it's absolutely their prerogative to go and do that. As I'm not saying there's anything wrong here, but I'm saying you have this inherent vulnerability when you have a single point of supply and no one else in the marketplace who can quickly switch on if something were to go wrong for you. And that's just one of these sort of rather inherent problems in bespoke processes for specialty semiconductors.
So there's a logical kind of follow on from that then. I mean, commercial considerations aside, I suppose more transparency around technology and testing and the sort of we would kind of neutralize some of the challenge there, right? I mean, is that just a pipe dream, or do you feel that there's enough momentum around that kind of movement to kind of say that it's happening or is as good as it could be?
No, you see, I think the proprietary process flows are just that. They're proprietary, and that's what makes it sticky for you as a business.
Yeah.
So you don't want transparency with that. I mean, there's a difference between a PDK and telling people how you do things.
Yeah.
They're not the same thing. You know, you want people to use your platform, but you don't tell everyone how to make your platform work.
Yeah.
And I'm sure you'd agree with that, right?
Yeah. Yeah. And I guess, Simon, you're obviously at the sharp end, or, you're being there's a lot of commercial sensitivity around your kind of work, I guess, where, you understand the kind of the science opportunity there, but the actual practical commercial realization is there. I mean, how do you manage that? I mean, is it just it's a closed shop and that's how it works, or is there more flexibility than that?
No, there is more flexibility as for us, especially we have a global footprint, so we can react to some extent to geopolitical
Yeah.
challenges. Other than that, the I think it's still the big part, the big chunk. I would say the main equipment manufacturers are still based like Europe or US. So
Yeah.
that might gonna change now. Also, price pressure will come or is coming. We see that as well. Maybe now changes again a bit, but yeah, again, tariffs, what's happening with the interest rates, this all impacts a bit. Yeah, if you build a fab for a couple of billions, it matters the interest rate you pay. So this all comes a bit together, and yeah, we feel that, of course. Yeah.
Okay. Andy, just as we're getting close to sort of wrap up, in terms of the time we've got, in terms of, your perspective, you're obviously close to government in terms of what they're thinking about, at least in terms of advising them, if not necessarily always as close to the decision making as perhaps you would want to be. But, taking the UK in particular, but perhaps governments more generally, how optimistic are you that things are on the right track and that this is going to get at least a bit easier or no harder?
There are certainly some very positive indications. So I think UK government has commissioned the Compound Semiconductor Catapult to set up the UK Semiconductor Centre. That's a
Yeah.
£90 million initiative. I think that's certainly a positive initiative. It's going to galvanise industry, coordinate across. There's lots of different pockets of capability across the UK, and I think that the Semiconductor Centre will be a great starting point to start to coordinate that activity, to attract inward investment, and also to work out international partnerships. So I think that's certainly a great initiative. Other recent initiatives, the £50 million for innovation knowledge centres. So innovation knowledge centres are housed at universities, but they actually work from low research base right out to commercialisation. So Cornerstone is an innovation knowledge centre. There's another one at Sheffield called Chimes, which is chip design and heterogeneous integration. There's one at Bristol called Rewire, which focuses on compound semiconductors, and there's one in UCL called Neuroware, which focuses on neuromorphic computing. So another great intervention for innovation knowledge centres. And I think there's also there is also a skills programme in the pipeline, and I think it's valued at £25 million because there's a recognised. So is it 35?
35, yeah.
Just checking before. Yeah, brilliant. Thank you for correcting me. There's a recognised 1 million shortage globally, so that 35 million will certainly go some way to get young people and start to address the shortage. Anyway, I think sort of more broadly, when the second semiconductor strategy was announced, it did indicate £1 billion of investment over the next decade. I think there's some uncertainty about how that is being delivered. So that is an interesting question.
Okay. It's my job to kind of, I suppose, wrap up a sort of summary of what I'm hearing. And I think, nobody would describe this technology as ubiquitous, or familiar, but it feels like it's something that is integral in terms of everything that's going on. But it seems to me we're in a tricky place, right? And, trying to forecast where it's going is almost as hard as trying to define a kind of bit of a snapshot of today. But it sounds to me like the challenge is probably greater than it was. We've heard that around the geopolitical context, but I guess, you know, the finance context is equally challenging at the moment. So it's a challenging place to be. Technology is moving fast, and demand is kind of arguably outstripping the advancements that we can see in the short to medium term. So it sounds like a topic we need to come back to. I think the three chaps who've been with us today have done a brilliant job of trying to kind of articulate some of that. And I think, you know, it's definitely a topic that we know our audience is very interested in. The online panel discussion we've just heard is going to remain obviously accessible on the Electro-Optics website. So that's electroopticsnospace.com, and it will eventually turn up on our YouTube channel. We'll also be creating an online article out of this in due course. So please spread the word among your colleagues if you've enjoyed the discussion or found it useful. Thank you to our three speakers. It's been a brilliant hour or so where we've really, I think, tackled quite a complex kind of set of, you know, areas and, you know, context. And we've done a good job, I hope, of giving people a bit of a flavour of our perspective on where it's going and where we're at today. Thank you, of course, to the production team working away in the background, and thanks again to Materion Optics for their help in putting this on. Thank you to you, everyone out there who's spent some time this afternoon watching it, and please keep an eye out for future sessions. Next week we have two. We're talking about laser safety on the 28th and endoscopy on the 29th. So thanks again for your time, both up to our panelists. Time is precious, and to everyone that's watching, you know, wherever they are. And we look forward to seeing you at one of our upcoming discussion panels in the near future. So thanks again, and hope to see you again soon. Thank you. Take care. Bye.
Thank you.